Hello everyone, so I'll be solving another LeetCode problem with the title reverse linked list. So let's read the problem first. Given the head of the singly linked list, reverse the list and return the reverse list. Pretty easy, right? So essentially we are given a linked list and we need to return the reverse linked list. It's a very easy problem, but it's a important one because a lot of other complicated linked list requires you to know how to reverse a linked list. So there are two solutions to it. One way of doing it is using recursion, and another way is using an iterative solution. Personally, I like iterative solution more because I understand what's going on. In recursion, I get lost a little bit, but that's personally me. So I'm just gonna show you iterative solution uh, in this video, but I'll most probably gonna make another video where I'll show how to do it recursively. So let's understand how to do it iteratively first. So let me just show you what I'm gonna be doing, or rather my algorithm to solve this problem. So let me write it down. So 1 is connected to 2, connected to 3, connected to 4, connected to 5, right? So one way of doing it is that let me just use 3 pointers. There will be previous pointer which will keep track of which the previous value is, the current pointer where we will be changing the connection. So right now, as you can see, 1 is connected to 2, which means that if we are standing on this node next is gonna point to 2, and 2's next is gonna point at 3, 3's next is gonna point at 4, and 4's next is gonna point at 5. But now in order for us to reverse a linked list, what we need to do is we need to reverse these connections. So 2's next should point to 1, 3's next should point 2, 4's next should be point 3, and fifth nodes should connect to point 4. And that's exactly what's going on, right? So we are just gonna flip the connections, but for that we need to keep track of what the previous node was, right? So for example, if I'm standing on 2, in order for me to change 2's next to 1, I need to know what the previous value is, and in order for me to iterate to the next one, so once I change this next arrow, if I'm pointing back to it, I also need to, because if I'm pointing it, if I'm changing the pointer directly, I would lost the track of where I am in the linked list, right? Because if I switch this from 2 next pointing to 3 to 2 next pointing to 1, I don't know, then I don't know where the 3 node is. So I also need to keep track of what's the next node. So there is a basic way to do it. We need to keep track of previous, current, and next one, right? So let me just code it down so that you will understand furthermore once I start coding. So let's just say list node prev, which for now we are going to initialize it as null pointer. Then I will be making another pointer which is current, and I'm gonna point it to head, and other pointer would be next, which is again gonna be null for now, right? So right now what we are doing is for previous, current, and next. For previous and next, I'm pointing to null pointer because right now we don't really know yet. But for current, I know we are on head, so we are starting off with the first. So now I'm gonna iterate until current is not null, or yeah, we already have current, so it's essentially while current. Now I'll be making connection, right? So now what I need to do is I need to keep track of the next function. So right now we are on the head, we need to keep track of 2 right now. So I'm gonna just store it into next. So next is current next. So right now current next is gonna be 2, so I'm just pointing next to this current next. And then again, since we also need to take care of this node's next, right? So this node's next, because in the resulting list, first next would be pointing to null pointer, so we need to do that too. So we are going to just say current next equals to prev, and prev right now in the first time it's gonna be pointing to null pointer as we want it to be, right? So once we have updated the next, we have updated the currents next. So now we are gonna just change prev to be current. So we also have to update current. So now since we have moved on to the another one, we need to change prev from null pointer to pointing it to the first node, the first one, and then again current. Again we need to change current to next now, right? Because next right now points to 2, and once I have created prev as 1, I have to also update the current in order for us to move on to the next node. And then once simultaneously all the links are gonna get flipped, at the very end the prev is gonna be on 5 and current and next are gonna point at null pointer. So at the end we'll be returning prev. Let's try to run this. Okay, it passes all the 3 unit tests or test cases. Okay, it got successfully submitted. So again, to recap really quickly, what we need to do is, since we are switching the connections, right? So rather than 1 pointing to 2 now, 1 next is going to point to null pointer, right? In the resulting one. 2's next is going to be 1, 3's next going to be 2, 4's next going to be 3, 5's next is going to be 4. So what we need to do is we need to keep track of previous node, next node, and current node. And we'll just keep on changing the currents next to prev or previous node, and gonna make a iteration while changing current to current next, which is gonna be next in this case. So this is what we are gonna do. We are just gonna have 3 pointers: prev, which is gonna be pointing on the previous node, current is the current node where we are doing the operation, next is the next node, which will keep track of what's the next node once we flip the next pointer to it, and we'll just iterate until current node is a null pointer or it's point to null pointer. And then the first step, we are gonna just say we're gonna save the next node into next pointer, and then I'm gonna update the current next to previous. That's where we are changing the current next to the previously created or previously existing node. And then previous is current, that means we are gonna change now previous is gonna be 1 from null pointer, and then current's next is gonna be essentially we are just saying current equals to current next, because next is pointing at current next. And then at the end we are returning prev. It's pretty easy once you understand what's going on. What we are doing is flipping the connections and keeping track of previous and next one, so that we don't in between we don't want the linked list to break. We just want to keep track of next and previous. I hope you understand it. This iterative solution, I think in my opinion, it's a little bit more intuitive than recursive solution. That's why I thought it's better to it's better to actually go with the iterative solution at first. But although I'm still gonna make a recursive solution or recursive video of recursive solution of this video. Yeah, I don't know why I fumbled, but yeah, that's pretty much it. Also, let me just tell you, write the time and space complexity. Time complexity for this is gonna be O of n, where n is the size of linked list, and the space complexity is gonna be O of n, right? Because we are not using any new space, right? We are just creating pointers which are does not take any significant amount of space in it. Complexity, I don't know why I just did. Yeah, so this is a solution. Let me know if you have any question in comment section. I'll take a look, and I also create a video for how to do this question recursively. All right, I'll see you in the next one. Thank you.